In this video we're going to take a look at an example of a question from the State Exams Commission, okay, based on equilibrium. Okay, we're going to calculate our value for Kc from the information that we're given in the question. So for this we're just concentrating on part C of this question. Okay, so when 208.5 grams of phosphorus 5 chloride is heated in a 100 litre container at a temperature of 500 Kelvin, equilibrium is established with 53.25 grams of chlorine gas present in the container. Okay, so first things first is we will look at our expression for Kc, which you were asked to write there in part B anyway. So your expression for Kc, you would have your products on top, okay, inside square brackets, okay, indicating the concentration of them. Okay, and underneath the line then, the concentration of your reactants. Okay, there are no powers here because everything is in a 1:1 ratio, okay, so there's no powers to go on any of the brackets there. Okay, so we're just going to rewrite the equation that's there. So PCl5 goes to PCl3 plus Cl2. Now, a bit of information they give us, okay, is that initially, alright, we have 208.5 grams of this phosphorus 5 chloride present. Okay, so they give us the mass of it, so we want to find the number of moles. So our moles are going to be mass over the relative mass. So 208.5 grams. Okay, if we actually go through our periodic table and find phosphorus, okay, and chlorine, we'll find that our mass, our relative mass of PCl5 is also it's also 208.5 grams. So overall we have 1 mole. We have 1 mole present. Okay, so that's the information we have right at the very start. So if we go and we draw our ice table, okay, so I standing for initial, C standing for change, and E then standing for equilibrium. Okay, so at the start we have 1 mole of PCl5. Right at the very start we don't have any of these. Okay, this is right at time 0 initially, before any reaction has really taken place yet. We have 1 mole of PCl5, we have none of PCl3 or Cl2. Okay, our change then, we're going to kind of substitute in a letter. Okay, so usually in maths anyway, we would substitute in x for an unknown. So here we're going to do the exact same thing. Okay, here we're going to have 1 and have minus x. Because this is all in a 1:1 ratio here, we don't have to worry about that. Okay, so here we're just going to have plus x, and we're going to gain an x here as well over the period of this reaction. Now, in our question as well, it says that we at equilibrium we have 53.25 grams of chlorine. Okay, so if we go and we do the same thing again, we try and find our moles. Okay, we find that actually this Cl2 comes out to be about 71. So that means we have 0.75 moles at equilibrium. That means that this X is also equal to 0.75 moles. In other examples that we'll see that you'll be doing as you go through exam papers, that's not always as obvious, okay, because you'll have different ratios between the different reactants and products, so it won't be as immediately obvious, but in this one it is. Okay, so that means we also, because they're in a 1:1 ratio, we also have 0.75 moles of PCl3. Okay, here we have 1 minus 0.75, so we actually have 0.25 moles. Now, that's the amount of moles we have at equilibrium, but it is not their concentration. Because if we look at our question again, we see that it says in a 100 litre container. Our concentration always has to be in moles per litre, so all of these all actually have to be divided by 100. Okay, so we're actually going to have 0.0025 moles per litre, 0.0075 moles per litre, alright, and 0.0075 moles per litre, or just big M for molarity. Okay, we then use these to sub in to our expression for Kc. So if we remind ourselves again, it's going to be concentration of PCl3 by the concentration of Cl2, okay, and the concentration of PCl5. Okay, so here it's going to be 0.0075 by 0.0075 all over 0.0025. Okay, that comes out to give us 0. So if we go 0.0075 multiplied by 0.0075, we'll do it step by step rather than skipping. Okay, so that would give us 5.625 by 10 to the minus 5 over 0.0025. Okay, and that gives us the final answer is 0.0225.